The revolution's begun. The time to stand up has come. We are the rocking of the throne. We are the rocking of the throne.
This is Victor Tiffany with Revolt Against Plutocracy, speaking today with Paul Beckwith. He's a professor of climatology at the University of Ottawa. He's a longtime member of the Citizens Climate Lobby in Canada. He has an extraordinary website, paulbeckwith.net, which is everything you ever wanted to know about climate change but was terrified to ask. Paul, thanks for joining me today.
It's great to be here, Victor.
So you caught my attention from a campus bench monologue you did a while back addressing the IPCC report and its shortcomings, particularly the baseline and this notion that we have 12 years to respond to climate change or else we're doomed. Would you speak to those shortcomings just to sort of set the framework up?
Sure. So one big flaw, and I mean, the report overall is quite good, I think. It goes a lot, in this report, the IPCC, Intergovernmental Panel on Climate Change, comes a lot closer to the reality of the situation, but they're not quite there on a few issues that I'll note. I mean, the first thing is that the baseline used is actually a shift from the original one. So years ago, when the policymakers around the world met, they talked about this 2 degrees Celsius guardrail, which we couldn't pass safely. That was sort of the upper limit. And in Paris in 2015, that guardrail there was an aspirational guardrail of 1.5 degrees Celsius above pre-industrial added. And the report says that we're 1 degree above the baseline, and their baseline definition in the report is 1850 to 1900, the temperature average. Problem is that the original temperatures, 2 degrees, 1.5 degrees, are based on a pre-industrial baseline, which is in 1750. So the difference between those baselines, that baseline shift is about 0.2 or 0.3 degrees. So we're more like 1.2 or 1.3 degrees above pre-industrial currently. We're rising about 0.25 degrees Celsius per decade. So in a decade or so, we'll pass the 1.5 using the proper baseline. And within a few more decades after that, we'll pass the 2 degree mark. Now, the problem is that we all know that climate change is happening faster than expected and it's accelerating. So we'll passing those guardrail temperatures in 10 years or in 30 years, that's assuming the present rate of warming, but the present rate of warming is increasing because of all the very strong feedbacks in the system. So the report doesn't assess those things accurately, in my view, and it doesn't account for all of the tipping points in the climate system, which could very rapidly take us much above those temperatures. And I'm talking about things like losing the Arctic sea ice and losing the Arctic snow cover. It's very likely within 4 or 5 years, we'll have no sea ice in the Arctic in the summer. So the Arctic will become much, much darker and the temperature will rise a lot more there. So this Arctic temperature amplification will greatly increase. So the problem is that the jet streams get disrupted and they guide weather patterns. So we're getting increases in the frequency, severity, and duration of extreme weather events like torrential rains leading to floods or droughts in other locations. And of course, it makes it very difficult for farmers around the planet to maintain high yields, which they need to do in order to feed the increasing global population. So we're between a rock and a hard place, really. We're going to have global food shortages with our present course.
That helps me segue actually into my next question. Some people think, well, the oceans are going to rise, and I don't live in a coastal city. I live in Ohio or Kansas, so I don't have to worry about this. Why does everyone really have to worry about let's call it runaway global warming?
Yes. Well, apart from the for each degree Celsius increase in warming, 1.8 Fahrenheit degree increase, there's about 7% more water vapor in the atmosphere. And this water vapor rises up. And when the gas, it's a vapor, when it condenses into droplets in clouds, it releases energy. So if there's more water vapor condensing, there's more energy to fuel these massive storms that we see. So these storms, look at these superstorm hurricanes that have been hitting the coast of the US. The ocean temperatures are much warmer than they used to be. So these storms are getting much more powerful. The jet streams are slowing and getting stuck and wavier. So these storms, once they go across the coastline, they don't just get whisked off across the land by the jet stream. They often will stall out, like Harvey and Florence, for example. They'll stick around. So Harvey, was raising the coast of Texas there for 5 days. It dumped 5 feet of rain in some locations. So, so apart from all of the storms, wreaking havoc on infrastructure, we're getting these heat waves, extended heat waves and high humidity. And crops just don't do very well. I mean, it's just too hot. So we're getting huge crop losses. The times when the harvest and when the planting and the harvest occur varies. The hydrology, the rainfall amounts have been changing significantly. So the yields, generally yields from crops have done quite well. They've been increasing and increasing and increasing, but at least in the last 5 years, last decade or so, they've plateaued and they're now dropping because of all these extreme weather events. So there comes a point, we have an exponentially growing global population, and we have a stalling of yields, crop yields, and there's only so much farmland. So also the few billion people that get their protein and food from the ocean, we're having less and less fish that are caught in the oceans, right? We fished out 90% of the large fish in the oceans. We are doing lots more coastal fish farming, if you like, but those are having their own problems. So we're hitting a wall in terms of the food supply. So food prices will spike, I think very soon, as we get a simultaneous loss of crops. So that's a big risk. It's going to affect everybody on the planet, basically.
Some people think that, this is just such a massive, it's a global problem. There's nothing we can do about it, or there's not enough that we can do about it. And that's the main reason I really wanted to speak to you, because you referenced your three-legged bar stool approach.
Yes.
That the 3 ways, it's not enough just to reduce carbon use, reduction of our carbon footprint, or reducing the use of fossil fuels. You also have to do carbon extraction, what some people call carbon capture. And then the third one I found interesting is solar radiation management techniques. And these are the 3 things I want to focus on in terms of, providing some shred of hope that, maybe we can do something about this. So let's just start with the first one, fossil fuel reduction. Of course, with Trump in the White House, very little is going to be done, but people could conserve energy, right? We could buy less new stuff. We could get lights off and things like that. So what kind of rate of decrease do you think we need? 10% a year, 5% a year, 20%?
Right.
In a realistic sense, how fast do we have to reduce our use of fossil fuels?
Well, I think it's been clear to me for many years that we're in a global climate change emergency. Our livelihood, our way of life, our civilization, our food supply is all threatened by abrupt, very rapid climate change. So I think the first step is that there has to be, enough people will realize this. Like more and more people are realizing this. And, there's some cities that are starting to actually declare a global climate emergency. So, I think we need to continue this awareness. I mean, as the climate is worsening, weather patterns are worsening, more and more people are being affected directly. So the number of people that are starting to become extremely worried and concerned about, how quickly the climate is changing and the weather mayhem is occurring, eventually we'll have enough people where, we convince governments and politicians to say, okay, we have a climate emergency on our hands. So we need to respond accordingly to like any other emergency. And, let's use a model like the Manhattan Project to build the first atomic bombs in World War II, the Marshall Plan, to rebuild Japan and Europe after World War II was over, and many of their cities and economies were completely devastated, or an Apollo moonshot type approach. But we need a global approach to do these three-legged bar stool things, to slash fossil fuel emissions at much faster rates than we're presently doing. But that's not enough. Like, it's not enough. We're still going to lose the Arctic sea ice. We're still going to have climate mayhem just by slashing fossil fuels. So we need to actively deploy carbon dioxide removal methods.
Before we get to the second
cool the
leg of that stool,
Yeah.
I want to just, do you think we can develop the alternative sources of energy fast enough to, fill in for what we're reducing, or is it going to have to be an also maybe impossible amount of conservation? Can we fill it in fast enough?
Yeah, it depends on how severe the pain is, right? I think the pain is becoming more and more severe to people all around the world. The pain from cities being destroyed and crops being destroyed and infrastructure being ruined in these torrential rains. I mean, all these cities, every week, every few days, there's other major catastrophes that are climate change caused, extreme weather events around the planet. So when the pain, and it's going to get a lot worse as we lose the Arctic sea ice and snow cover. So, it can get 10 times worse, 20 times worse easily, in a matter of years with the loss of Arctic sea ice. So when the financial pain and the human suffering and pain from all of these events gets severe enough, then we can declare the climate change emergency. And then, I like to use the example of the US military. When the threat to the US and the rest of the planet becomes from the climate, not some other sovereign power, then what about taking a year or two and spending the US military budget on the ways to extract carbon out of the atmosphere, on ways to cool the planet so that the Arctic sea ice doesn't go? That would stabilize sea levels. We're fighting the wrong enemy, really.
Right.
So the resources, so we've got thousands and thousands of top-notch scientists developing ever better ways to, ever better technologies to kill people, with better missiles and better weapons, etc. Let's put these people to figuring out how to preserve, our life and civilization on this planet by figuring out how to suck, like if we could remove CO2 at twice the rate that we're putting it in at, right, at the moment, and then even cut back the amounts that we're putting in by retooling from fossil fuels to renewables and geothermal and all of these other techniques, right, then we need to lower the CO2 level in the atmosphere, because if we just stabilize it and let it be at about 410 parts per million of CO2, there's a lot of different time lags in the system. So, the stable sea level, for example, will be 10, 20 meters higher than it is today with that CO2 level. The stable temperature will be much, much higher than 1.5 or 2 degrees at that level. It will just take time to get there because the oceans take time to respond.
So let's talk about carbon extraction techniques. I know I've read an article about, different ways of farming that will actually help sequester carbon.
Yes.
Which is one step or one thing that can be done. But, you know, and I've also read about artificial trees, and of course there's real trees that we could plant more of instead of cutting them down.
Yes.
Do you have any promising technology, or are you aware of any promising technology that would extract carbon and possibly either reuse it as a solid or sequester it somehow?
Yes, there's a number of very interesting technologies, which I think, which I would, they're the horses in the race that I would back. You know, it's not going to be one solution solving the problem. It's a multitude of things, and just what could we, you know, what can we scale up the fastest, right? Because it's got to be scalable to, you know, global levels to extract huge amounts of CO2. So of course, trees, you know, continuing to destroy forests and so on is not the way to go. And of course, but trees are, you know, trees are quite vulnerable to wildfires, right? So, you know, if the conditions are such that, you know, we can grow all kinds of trees, but then if huge wildfires take them down, they quickly destroy the carbon sink. And they also, you know, all that carbon that's stored in the trees goes up into the atmosphere in one shot in these fires. So some of the most interesting ideas is, you know, we need to use the oceans for sure. Okay, so I mean, the oceans are you know, 70% of the planet, right? I mean, why should we only just think of things on land? So we can stimulate phytoplankton growth, and then the zooplankton will eat the phytoplankton, and it'll go all the way up the food chain, and we need to revitalize the teeming. The oceans used to be teeming with life, and now they're not. So we can, you know, help the oceans along by various methods to, and there'll be huge amounts of carbon that is then captured within the oceans. So a very interesting idea, another interesting idea is things like clams. They take the CO2 in the water and they react it with calcium, and they form the calcium carbonates of their backbones, which is a very hard material in the shell of the clam. Well, concrete industry, cement industry is huge, right? It's huge, and it's growing, and it uses huge amounts of mining of both rocks. I mean, basically, concrete is the cement is 80% is rocks, basically 10% is limestone, and 10% is sand. And that limestone is basically calcium carbonate. So if we can take the carbon out of the air and oceans and use it to produce the limestone, the calcium carbonate that goes into building materials, aggregate, that would be a huge reduction of CO2 from the atmosphere. So there's a company called Blue Planet that has got some pilot projects to work on that very thing. Many other companies are looking at ways to take conventional concrete and have different compositions so that it doesn't outgas, because it produces a lot of CO2 in the construction, you know, in the pouring of the concrete. So that's a really interesting idea.
Do you see the potential or the need for a combination of market ideas along that line?
Yeah, yes.
And command economy mandates and things like that, both?
Yeah, well, I think that, you know, we need to put a lot of research money into, you know, on an emergency basis into these technologies so that we can scale, you know, and work on all different ones so that and scale them up, you know, because that's the big problem, you know, scaling. Are they scalability? You know, and which ones are the least expensive to do, which ones are the most effective. And, you know, I think, you know, we have to do this, whether it works or not. You know, so this is carbon dioxide removal. There's some very interesting technologies that combine the carbon dioxide removal with the solar radiation management. I mean, the biggest thing that people might be aware of for solar radiation management is big volcano goes off, puts sulfur up into the upper atmosphere, cools the planet. So Mount Pinatubo, when it went off in 1991-92, big volcano in the Philippines, it cooled the planet about 0.5 degrees for up to 3 years, just because of the sulfur dioxide in the upper atmosphere, in the stratosphere. So we can actually, for example, you know, we could put sulfur in airplane, you know, commercial aircraft fuel, you know, and they fly up you know, at the lower stratosphere, and that would put a layer, and that would cool the planet. I mean, we can do these things very
Some
quickly.
people think that's happening now. They talk about chemtrails.
Yes, they do. Unfortunately, they're sadly, you know, incorrect. There's not, no scientists think this is going on. This is a, you know, and if it was, it's certainly not working. The planet is warming like crazy, right?
Right.
So, but there's something called iron salt aerosols. So what you do is you create things like iron chloride. Okay. Now, naturally, when the Earth is colder, there's more dust coming from Africa, say, over the ocean. So there's more, and there's iron in the dust, and that iron goes into the oceans, and it stimulates phytoplankton blooms, which, you know, plants, which suck lots of CO2 out of the atmosphere, lowers the CO2 level, and then cools the planet. And then there's even more dust created. So that's the sort of cycle that brings you to colder and colder temperatures. So we can try to do that type of thing now with these iron salt aerosols. We take these very small iron chloride particles and we put them, you know, just a kilometer or two above the Earth, and they do a number of different things. One thing is they act as cloud condensation nuclei for creating more low-level clouds, which cools the surface underneath because it reflects sunlight. It also the iron reacts with methane and nitrous oxide and some of these other greenhouse gases, so it reduces their concentrations. Eventually, the iron precipitates into the ocean, you know, in very, very small micro quantities, tiny quantities, but the oceans, a lot of the oceans are barren deserts essentially because there's no iron. So even iron micronutrients, you know, if that's the missing limiting factor for phytoplankton at the surface to grow, then this iron will create these huge blooms of phytoplankton, which will suck up large amounts of CO2. So this is a very promising idea, the iron salt aerosols. Another idea is to have these buoyant flakes, for example. I mean, we take things like, you know, corn husks and things like that, and we coat them with some nutrients, and we, you know, we put them in the ocean, and they float around and disperse on the surface of the ocean, and they release the nutrients very, very slowly, including iron and, say, potassium and nitrogen and things like that, and they stimulate the phytoplankton blooms around the ocean. But why just have the phytoplankton blooms? I mean, you can think of, for example, these arrays, these arrays floating in the middle of the ocean, say near the equator, where there's very little sea life. And what you can have is you can have these long tubes going deep into the water, and there's a one-way valve on the bottom of the tube, and waves lift the tube up and then bring the tube back down. And basically it brings up a plug of cold water from a couple hundred meters down. That water is laden with nutrients. Those nutrients stimulate the phytoplankton bloom, but you have these arrays that are floating, allowing things like seaweed to grow on them, kelp beds and mussels and all these things. And you can stimulate sort of an artificial floating reefs, if you like, you know, near the equator that suck huge amounts of CO2 out of the atmosphere. So, you know, it's just a matter of putting our minds to it, of saying, hey, we can't just keep doing what we're doing. We have a problem here. Houston, we have a problem. So let's do something about it. But we need lots more people. First, you know, I mean, if you don't understand how serious climate change is, that it's an emergency, then there doesn't seem to be, there won't be an urgency to do these things, right? So so it's a step-by-step process. I mean, you're not going to get huge money going to these solutions unless the general public really starts to understand how serious the risks are of you know, in the direction we're heading.
Right. So I have a couple more questions. Let's talk about the radiation management techniques. Some of your solutions might make people nervous. Oh, you're messing with the chemistry of the Earth. You're introducing things into the atmosphere, and that always has a way of sort of backfiring on you. What do you think about space-based systems? Maybe there's two that come to mind. One that might be positioned between the Earth and the Sun that is positioned so it's this big array of umbrellas that can be adjusted for more or less sunlight coming through almost in real time.
Yes.
the radio delays, and that it could be possibly moved around to cover different sections, maybe the hotter portion of the summer section of the sun. I'm sorry, of the Earth.
Yeah. Yes.
So, and
Yeah.
then there's also the possibility of a satellite around the Earth,
Right.
which at nighttime isn't going to do anything, but in
Yeah.
daytime hours, it also,
Yes.
both of these are very huge, very expensive projects.
Yes, that's the thing. I think we need to generate the ideas. You know, we need these ideas. We need more and more of these ideas, and then, you know, worked on by engineer. You know, can we do it? And then, of course, you know, we need the economists and the financial people to come in and give cost estimates for every single one of these ideas, and then rank them according to, you know, what makes the most sense. It's not just the cost that's important. You know, if we're trying to save the planet, you know, then surely eventually, you know, if things are bad enough, then cost will not be an obstacle to stop any of these. I think the big thing is deployment.
Anyway.
Well, it's deployment,
cost should
right?
be no object, because
Yeah. I mean, we're
not on the gold standard.
all or nothing. No, I know. And also, but, you know, there's a big time lag to deploy a lot of these things.
Right.
Right. Like you know, we could go and put sulfur in jet fuels that, you know, all the commercial flights around the world, you know, put a little bit of sulfur in their fuel. So when they burn it, they put sulfur into the stratosphere, cause it, you know, cool the planet, you know, you know, tweak it, you know, okay, we don't want too much cooling. We want about half a degree or a degree. You know, we could start doing these things right away. Right away, you know, it might take a few months to, you know, set up or something, or, you know, a year at the most. Like in an emergency situation, I think that's what we're going to end up doing.
Right.
But you know, these and you know, it's you know, but I mean, if people don't recognize we're in a climate emergency, then none of these things will get the money and the push. But we're seeing things change. I mean, with the IPCC report, you know, it's still sort of, you know, in the background. You know, lots of people are aware of this report. In the 12 years we have to do something, you know, so that's a step in the learning process of how serious things are. And then, you know, in a few years we'll actually, you know, lose sea ice in the summer, and things will skyrocket, you know, in a bad way.
Right.
Extreme weather events, etc. So there'll be eventually an awakening, you know, by the public, you know, or panic, if you like. Okay, we got to do stuff. You know, we're shooting ourselves in the foot collectively, the human civilization, right?
Yeah.
So then money is less of an object. It's how quickly can you deploy things. So
right. One last question has to do with a problem that some of us locally here have discussed, and we just don't have an answer for it. And it's on your website. You show these lakes that sort of pop up out of where I guess the ice is melted or something.
Yeah, the methane. They don't freeze in the winter because of
right,
the bubbles from the
you
methane
show
coming
bubbling methane coming up through that, and the methane is being released not just there, but along continental shelves, up in the Arctic, and over the permafrost zone. Are you still with me?
Yes, I am.
How do you capture that? I mean, methane is way more potent of a greenhouse gas than carbon. How do you capture these bubbling up methane?
Well, see, methane is the real wild card. I mean, the IPCC doesn't think it's going to be a problem for a century, right? You know, I mean, just, you know, the Russian scientists that have been up on the eastern Siberian Arctic shelf are measuring big plumes of methane coming up from the seafloor because the water temperature, you know, is up to 5-7 degrees Celsius warmer than normal, right down to the seafloor on these continental shelves.
So
it's one of the largest continental. Well, the thing is how do you capture it on an enormous continental shelf? You can't really, right? You have to stop it from coming up. So this is why we need to apply the solar radiation management to cool the Arctic, to buy us time for the carbon dioxide removal methods to get the CO2 from the 410 down to 350 and 300 even. You know, that will also stabilize the jet streams because the Arctic will be colder again. And that will also ensure that sea level rise doesn't continue to rise exponentially. I mean, it's not just the Arctic, it's the Antarctic. I mean, melt rates from parts of Antarctica have tripled in the last 10 years. Melt rates on Greenland, basically, you know, the doubling period is about 7 years. I mean, that report that said that, the melt rate in Antarctica has tripled in 10 years, that would mean a doubling in about 7 years, and then, tripling in 10, and it would be, 4 times increase in 14 years, if the doubling period is 7 years. And that's about what it is for Greenland and melt and for Antarctic melt. So, sea level rise it's accelerating upwards, and it has huge impacts, of course, on coastal cities, coastlines around the world. So we're in an emergency situation. I mean, people just need to recognize this. There's no beating around the bush on this, but we're not, the idea of hope, do I hope this is going to happen? I mean, I don't know.
You're taking my next question right out of my lips.
Well,
because it helps motivate people if they have some sense of, God, we can get a handle on this.
Okay.
It is worth spending the money.
Yes.
What is your sense of hope that
well,
be able
the
to
thing is,
around?
Hope can, it can destroy when hope isn't realized, right? When you hope something and it's never realized, it chips away at your psyche, right? It chips away. And, eventually some people just lose hope completely, right? I mean, I try to think of, rather than have hope, I don't say I have a lot of hope per se, but things aren't hopeless either. I think we just, we have to do what we can, and we don't know the final result for sure, right? We don't know. I mean, for somebody who says we're all going to be dead in 10 years, how do they possibly know this, right? I mean, what are they saying? A big methane pulse comes up. I mean, if a big methane pulse comes up from the Arctic, talking about 50 gigatons, maybe 5 gigatons a year for a decade, for a total of 50, or 50 in the space of a few years. This was in Peter Wadhams looked at this with an economist. That type of emission coming up would increase global average temperatures about 0.6 degrees in the space of a year or two. So that would blow us, well past the 1.5, well on the way to 2, if that happened. Now that would be sort of an episodic type, burst event, with a great, and the risk of that happening becomes ever greater as we lose the Arctic sea ice and as the Arctic continues to warm. So, are we going to wait till it happens before, trying to cool the Arctic in a panic? I don't know. I don't know how this is all going to play out, but I just, I can just see where the scientific trends are. And, if we continue to do things as we are, then the risks become greater and greater and greater of enough carbon being emitted from the biosphere that it maybe won't matter what we do at all. If we reach a point where it's just coming out too fast, then we have to live with eventually a world without any snow and ice up in the Arctic, for example. I mean, how many people are going to, pull through this, right? There's going to be countries that basically drop off the face of the earth.
And cities.
And, I mean, ironically, the US is extremely vulnerable to all of these things, more so than, say, Canada, or more so than, say, northern China, for example. It's vulnerable because these hurricanes are getting larger and more intense as the seawater warms, and they're lingering for longer, and basically, they can raise the entire coastline. I mean, we've dodged bullets in the last few years, as bad as the hurricanes have been in the US. What about, Maria took out Puerto Rico, right? There was what was it? Irma was heading and about to take out Miami and Palm Beach and the whole east coast of southern Florida there. But, in the last 10 hours or so, it veered to the left and came ashore in the Everglades and went up a much less densely populated part. If it had continued on its path, not veered in that 10 hours, we're talking about $1 trillion of damage up the east coast of Florida. So we dodged, as bad as these storms are, we've dodged bullets. I mean, Florence, what if it was a bit further north? What if it was hitting Boston or coming into Washington and, Philadelphia? What about right? I mean, these things, it's like a climate casino, I call it. On any given time, some city just fails, runs out of luck in the climate casino and
Right.
gets hammered, right?
Do you see the possibility? I mean, I don't. I've heard of this, but the possibility that the runaway global warming would be just feedback loop after feedback loop into a situation
Cascading
that's
loops.
way beyond anything the humans
Yeah.
can survive in.
Yeah.
We're dealing with human extinction, maybe not in 10 years, but at some point in the fairly near term future, in terms of 500 years or 1,000 years.
Yes. So the hothouse. So before I didn't properly. I'm going to go back to a previous question you said, like, what about the people that say the risks of tinkering with carbon dioxide removal and solar radiation management, they're so dangerous and stuff. Well, you have to compare the risks of doing something with the risks of not doing something, right? So in order to be concerned that these techniques will be far worse than doing nothing, you have to be able to convince people that, business as usual, what we're doing is not going to get far worse. And I don't think you can do that, right? I mean, the damages and the pain from what we have right now is getting more and more severe all the time. So we have no choice but to, I'm saying we have to very quickly, I think people's understanding that, we're in deep trouble and this is an emergency and we have to start deploying what we can as soon as possible. I think more and more people will come around to that view. In terms of a hothouse, this is a problem with these cascading feedbacks. Like if we time's not on our side here. So, I would argue we've already passed tipping points in the Arctic, like the sea ice, unless we actively try to cool the Arctic, even the carbon dioxide removal, the momentum's there. I mean, we've got this runaway train, and it's heading to no sea ice, and a large increase in extreme weather events. So it's very difficult to stop that unless we actively try to, say, regrow sea ice, for example, through various techniques. Unless we try to actively cool the Arctic, like from the atmosphere, reduce the solar radiation there in the summer, for example, then we're going to completely lose it. Now, I would, what I think is going to happen is I don't think the pain is quite there yet. I think in a few years, when we start losing sea ice early, by late summer, maybe September, and extreme weather events notch up, a couple of orders of magnitude, then the pain at that point will be, okay, we have to do what we can. This is crazy. We can't, but the unfortunate thing is the trends are all there. I mean, if people just look at what is going on, and we need more scientists to join the dots on climate change, not to do their own specialized little niche of climate change, then, you can't not reach the conclusion that we need to do these things as soon as possible to have the best chances of success.
Well, with that, I think I'm going to end this. I appreciate your time and your expertise on this subject, and hopefully by election 2020, we'll have enough people voting for some sort of mass mobilization,
right? Yes,
and get things going at the federal level.
Yes, I mean it's a matter of time until we do this. I don't think we have any choice. So and I'll be sure to blog this out on my website, paulbeckwith.net, as soon as you have the links for me and stuff. And it's I mean we need to, we're all there's a famous saying that it talks about spaceship Earth. Right. Like we're not passengers. None of us are passengers on spaceship Earth. We're all crew.
Right.
So what are we going to do? We're not doing what's necessary at the moment. People are unaware of even the dangers that we faced. Right. But we're all crew, and the sooner people recognize this, the better things can be in our long-term prognosis or outlook.
Well, let's hope this helps. Again, I appreciate your time.
Well, we can only try, right?
Revolt Against Plutocracy won't just be covering the news about the necessary revolution in the United States. Sometimes we'll be making the news. If you want to stay on top of the revolutionary actions and strategies of grassroots, genuine progressives, and our allies, please subscribe to our YouTube channel today.